You're made of the rarest material in the universe, and that's not a metaphor. Right now, as you watch this, you represent less than 5% of everything that exists. Everything you've ever touched, seen, or experienced, every star in the night sky, every galaxy we've photographed, all of it combined is basically a rounding error in the cosmic census. We are the minority matter, and we've lost 95% of the universe. In 1933, a Swiss astronomer named Fritz Zwicky was studying the Coma cluster, a group of over 1,000 galaxies, when he noticed something impossible. These galaxies were moving way too fast. According to every calculation, they should have torn themselves apart and scattered across the cosmos millions of years ago. The gravity from all the visible stars and gas wasn't nearly enough to hold them together. Zwicky proposed something radical. There had to be invisible matter we couldn't see, what he called dunkle materie, or dark matter. The scientific community largely ignored him for decades. Fast forward to the 1970s. Astronomer Vera Rubin was measuring how fast stars orbit around the centers of galaxies. Basic physics tells us that stars farther from the galactic center should move slower, just like Neptune orbits the Sun much slower than Earth does. But that's not what she found. Stars at the edge of galaxies were moving just as fast as those near the center. It was like watching a merry-go-round where the horses on the outer edge spin at the same speed as those in the middle. This breaks everything we know about gravity and motion. Unless there's more mass than we can see, invisible mass creating gravitational pull throughout the entire galaxy. Here's where it gets uncomfortable for physicists. When they calculated how much invisible matter would be needed to explain these observations, the number was staggering. Dark matter makes up approximately 27% of the universe. Everything we can detect with our most sophisticated instruments, is just 5%. But wait, we're still missing 68% of the universe. In 1998, two independent teams of astronomers were studying distant supernovae, expecting to measure how much the universe's expansion was slowing down due to gravity. Instead, they discovered the expansion is speeding up. Galaxies are accelerating away from each other, pushed by some unknown force that works opposite to gravity. They called it dark energy, not because they understood it, but because they had no idea what else to call it. Those teams won the Nobel Prize in 2011 for discovering that we don't know what makes up most of our universe. Let's be clear about what dark matter and dark energy are not. Dark matter isn't just dim matter or matter that's far away. We've looked. It doesn't absorb light, doesn't reflect light, doesn't emit light. It doesn't interact with electromagnetic radiation at all. It only interacts through gravity. Dark energy is even stranger. It's not a substance or particles. It's a property of space itself, and the more space there is, the more dark energy there is, pushing everything apart faster and faster. Scientists have built detectors deep underground, shielded from cosmic rays, filled with ultra-pure xenon or other materials, waiting to catch a single interaction with a dark matter particle. Experiments like Xenon 1T in Italy and LUX Zeppelin in South Dakota have been running for years. The results? Nothing conclusive. We've spent billions on these experiments, and we're essentially hunting ghosts that we can only prove exist through their gravitational fingerprints. Some physicists propose dark matter is made of WIMPs, weakly interacting massive particles. Others suggest axions, theoretical particles so light and numerous they could be streaming through your body by the trillions every second. There's even a theory called modified Newtonian dynamics, or MOND, which suggests maybe gravity just works differently on cosmic scales, and there is no dark matter. But MOND struggles to explain what we observe in colliding galaxy clusters, where we can actually map dark matter's location using gravitational lensing, watching it bend light from galaxies behind it. The Bullet Cluster observation in 2006 provided some of the strongest evidence for dark matter. When two galaxy clusters collided, the normal matter, hot gas, slammed together and slowed down, glowing in X-rays. But the majority of the mass, detected through gravitational lensing, passed right through. The invisible mass and the visible mass separated. It's like watching two cars crash, but their shadows keep driving. As for dark energy, the leading explanation is that it's the cosmological constant, a property Einstein originally added to his equations, then called his biggest blunder. Quantum field theory predicts empty space should have energy, but when physicists calculate how much, they get an answer that's wrong by a factor of 10 to the power of 120. That's not a typo. It's the worst prediction in the history of physics, off by 1 followed by 120 zeros. What's truly disturbing is this. We've built our entire understanding of physics, chemistry, biology, and technology on the 5% we can interact with. We've split atoms, mapped genomes, created artificial intelligence, and sent probes beyond our solar system, all while being fundamentally ignorant about 95% of reality. We're like people who've mastered building sandcastles on a beach while being completely unaware of the ocean. The James Webb Space Telescope and upcoming experiments like the Vera C. Rubin Observatory are collecting data right now that might crack this mystery. Or they might deepen it. Every answer in cosmology seems to generate 10 new questions. So here's what I need to know. Does it terrify you or excite you that we're basically walking around blind to 95% of existence? Drop your thoughts below and follow for more mind-bending science that'll change how you see reality.